Go ahead, please.
Yeah, in encapsulation, you like told the three-way handshake, right?
Correct.
Like when do we like when and how do we like use the four-way handshake?
Like I said, once the data transfer is complete. Okay, well, let me
Mm-hmm.
explain it to you with the diagram.
Okay.
So in case of encapsulation,
Okay.
encapsulation means wrapping of data. So from top to bottom, you'll have encapsulation process involved, and
Mm-hmm.
from bottom to top, you'll have decapsulation process.
Decapsulation.
This happens at the
Yeah.
destination end. Now, coming back to your question, this happens at the source end. When is the four-way handshake seen? Is that what you're asking, correct?
Yeah.
Okay. Firstly, three-way handshake is done, then the data transfer happens over here. You can say that this is the data transfer. Once this
Okay.
data transfer is done,
Mm-hmm.
for example, like the way I explained when I'm taking the remote access of a server specifically, right?
Mm-hmm.
Once I close the connection, let's say I take the putty. Yesterday I've shown you, right? Some tool called putty.
Yeah.
When I opened it and when I've logged into it, I'll get the access of the server, correct? Remote access of the server.
Mm-hmm.
So at the back end, when I was logging in, there was three-way handshake involved in between them.
Yeah.
Once that is done, I'll get the access. Fine. Once I
Yeah.
have the access, the moment I close the putty or the moment I exit from the putty, what happens? You'll see the connection is terminated. You'll see the four-way handshake process. Am I clear?
So okay. So you don't have to like initialize anything in
No,
phone-way
no.
handshake.
Are
Okay.
you initializing three-way handshake?
Not exactly, but yeah, I get the point.
The point, right? This is something which happens at the back end. We are not
Okay.
initiating anything. We are just depending on the service which is visible to you or which is visible to us is only in terms of port number. Let's say 22 or 23. And not even
Mm-hmm.
that. You're just going to putty, specifying some IP address along with the port number. Then you'll get the access, right?
Okay. Yeah.
That is the only thing which is visible to us. But at the back end, what is happening? It is with let's say telnet packet is encapsulated, then after that it is
Mm-hmm.
given to presentation, then followed by all the OSI layers, then uh, firstly from the application to transport. In the transport, the three-way handshake happens. Fine. Once the
Mm-hmm.
three-way handshake is done, the next thing
Mm-hmm.
the next thing is you'll get the access, remote access of
Okay.
that particular device. Once the remote access is done, once you close the connection, then what happens? You'll see the four-way handshake process. And the question might arrive, where can I see that exactly? In the Wireshark capture.
Yeah.
Okay, am I clear?
Yeah.
Not only that, you can turn on Wireshark. Okay, you initiate some traffic towards web browsing. Browse any website in any browser. Okay, and you close that website. While you're browsing,
Okay.
turn on the Wireshark capture. Then
Mm-hmm.
close that website. Once you've browsed it, you'll see both three-way handshake and four-way handshake. Also the data exchange as well. Am I clear?
Oh, okay. It's clear.
Okay. Any more doubts or questions?
No, not right now.
And Ritesh?
I am Ritesh.
Yeah,
Okay,
Ritesh
Ritesh.
only asked.
Yeah, okay. How about Purna?
No, not right now.
Are you really going through videos or not?
Yeah,
Firstly,
I'm going through videos.
yesterday something, now you tell me whether I have discussed something called subnetting or not.
No, you haven't discussed subnetting.
Okay,
So
no
I have
worries.
gone through all the videos.
Okay, then I think I have explained it to different batch, I believe. No worries. My bad. I'm sorry about that.
Yeah, that's fine.
So do you want to see subnetting today, or do you want to understand the ping process?
Let's go with the ping process.
Yeah.
Yeah, sure. So basically, like I said, let me share my main screen firstly. Okay. Uh, okay, this is my main. Yesterday I've shown you something with command prompt opened. If you type this command ping and then enter, you have different customizations on the command. Okay. This is something which is actually taken care of by the server team. Reason why I'm saying server team, because Windows Server is a part of server team. Okay. And they are the ones who are responsible to generate anything. It not necessarily for them. You, if you want to learn, you can learn it as well, just to customize the things. Now here, what are the things which are familiar to you? First of all, if you look at these parameters, please go through it once. Tell me what are the things you are familiar with as of now.
None.
None? I see something time to leave. I see something type of service. I see something don't fragment. I see something buffer
Okay,
size.
yeah, don't fragment. Okay, okay, okay. Time to leave.
Correct? I see something
Yeah.
source address.
Mm-hmm.
Correct?
First unit. Yes.
So there are some parameters which are already covered. Fine. Only thing is
Mm-hmm.
you don't know that those are all covered here in this specific ping process. Okay. Now
Yeah.
we'll go with the command. This is the ping, and ping, after entering ping, you need to mention a specific IP address, be it any of the IP address, for example, 1.1.1. This is also Google server's IP address. Okay. Now, practically to understand, just as an overview, I have some questions over here. Okay. Firstly, when you have run this command, what are you seeing? Do you see any request?
No.
Mm,
You're seeing what? Reply, correct?
reply, yeah.
Mm-hmm.
How many packets are generated?
4,
4.
4 packets are generated. Each of how many bytes?
32 bytes.
Correct. 32 bytes. Okay. Now, this approximate round trip time in milliseconds means, okay, firstly, before that, there's one row, packet sent. I have sent 4 packets. I have received 4 packets. I have 0% loss. Okay. Now, ping statistics for this specific IP address is shown below. Fine. Now, approximate round trip times in milliseconds. What does that mean is how much time is taken from my source to destination and vice versa. This is called round trip, to and fro. Am I
Yeah.
clear?
Yeah, it's clear.
Okay. What is the maximum value? What is the minimum value? What is the average value? These are the calculations depending on the round trip. Is this thing clear?
Yeah.
Yeah.
So far, any doubts up to here?
No.
Okay.
No.
This is something automated. Okay. We don't have any control on it. Fine.
Okay.
Okay.
Okay. Now let's start with the backend process. What exactly is happening at the backend? So ping. Ping stands for packet internet gropper. It is basically a unidirectional utility which is used to check or which checks. Okay, am I clear?
Yeah.
Now, there might be a question. For example, what I have explained in the definition and what I mean by that definition is, let's say there are two devices. With this ping, on any one of the device, I'm running a ping command. I'm just pinging this particular device. Okay. What is the reason for me to call it as unidirectional? It should be bidirectional, right? But bidirectional is only the thing when other device is also initiating some traffic. He's not initiating any traffic. Beyond that, he's just responding to the traffic which has been initiated by the source device. Am I clear with this thing?
Okay.
Okay. So this is the thing. This particular device is just a responder to the request which is received from the source. So that is the reason why I call it as unidirectional utility, and which checks the reachability between two devices. Only two devices? Yes, only two devices. That too at a time. Am I clear? At a time, it can check only two devices only, not more than that.
Okay.
Okay.
This is my definition, what I have explained it to you. Fine. Now, let's start with what does the PC do when we run the command ping? PC will call a protocol named ICMP. Okay, ICMP stands for okay. Now, first question. I have told the definition of ping. Okay, what is ping exactly? And I told that it is checking it is checking the reachability between two devices. The question comes, how does it do that with the help of ICMP? Okay, so now PC will call protocol named ICMP whenever this command is entered. Okay, now after that, what firstly ICMP is layer 3 protocol. Layer 3 means which layer?
Ne-
Tell me, tell with confidence. Don't be.
Transport layer.
Network layer. Network layer.
See, you should first remember the OSI model. Okay, all
Okay.
people seem to need data processing. This is the easiest way to remember OSI. Everything will revolve around the layers only. If you are perfect with the layers, any advanced concept can be understood easily, very easily, within your fingertips. Okay, please be sure with the layers. Please read them. Please try to remember them. Fine. Now, network layer protocol is ICMP. Now, ICMP has ICMP uses two messages for ping. Okay, first message is Next message. Okay, well, these messages are for human understanding purpose. Now the question comes how the machines will understand whether this is ICMP echo request or whether this is ICMP echo reply. So depending on this thing, type 8 code 0. For reply it uses type 0 code 0. Now again, this is human understanding purpose. Now, for machine understanding purpose, it is written something like this, hexadecimal. Am I clear?
Yeah.
Yeah.
Now, let me highlight it. Now, when the ping is returned, for example, I'll take example of two devices. This is my PC. From this PC, I am generating ping to another PC in the same network. Okay, so
Okay.
the IP address of this PC is, I'm considering this one with /24 value. The IP address of this one is I should have some MAC address, right? For this
Mm-hmm.
device. I'm considering the MAC address for simplicity. I will write it as, am I clear? In the same
Okay.
way, it would be 0B. Okay. For simplicity, I'm writing it as fine.
Okay.
Now, I'll go into the command prompt of PC1 and I would write ping which device. Fine.
Uh, yeah.
Mm-hmm.
The moment I enter this thing, PC will call which protocol I told.
ICMP.
ICMP.
Now, after calling ICMP protocol, what the ICMP will do?
Echo request.
This thing is clear.
Mm-hmm.
Now, how does it look exactly is this manner. ICMP echo request with what? Type 8 code
Code 0.
0. This is my ICMP echo request generated in which layer?
Network
Network
layer.
layer.
Okay. After generating this thing, ICMP's job is done. Now what it will do? It will hand over this to which protocol?
Layer 2.
Do you think it will go layer 2 directly?
Okay.
No, apply logic. Don't confuse yourself. It's very simple. See, do I have any header here? I accept ICMP. Do I have any header here?
No.
Then without the header, how will layer 3 job be completed? What is the main protocol involved in layer 3?
Segment.
How come segment came into layer 3?
Packets.
Okay.
Packets to the
See,
layer.
apply your logic. It is handover to which layer, which protocol? Inside layer
It's
3
handover to
only.
level 2. Okay.
Layer 3 only. Inside layer 3 only, it is handover to which one? Okay. Along with the ICMP.
Okay.
Now in this, along with this one, what is the thing which is given to it? What is encapsulated?
IP header.
IP header, exactly. Which field comes first? Source IP, right?
Yeah.
What would be my source IP?
10.1.1.1.
Okay.
Yeah.
Now, what would be my next field?
Destination. 1.1.1.2.
2, correct? Now, what would be my next field?
Type.
Oh, protocol.
Okay.
Okay.
What is the protocol number for ICMP is? It is 1. Am I clear?
Okay. Mm-hmm.
Yeah.
Now, what is my TTL? Which device am I generating this one?
Windows is
Okay.
128.
This is how you need to study. Am I clear?
Okay.
Only then you'll understand. Now, what is this entire thing called as?
Packet.
Okay. Now, layer 3 job is done. Fine. Now, before handing over this particular packet to layer 2, what the PC does is PC will perform, well, I'll write a note. Do you know what is AND operation?
Yeah.
Logic gates, remember in
Logic.
BTech.
Yeah.
Okay. So AND operation. Why it is performing AND operation?
To check if it is in same subnet or not.
Correct.
Is that correct? Okay.
See, be familiar with the terms subnet, network. Okay, both are same terms. You can call it as subnet or you can call it as network. Am I clear with this thing?
Okay.
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 For now, I am calling it as network. You can call it as subnet as well. Same
Okay.
network or different network. Okay. Now, how this AND operation is performed? Let me explain it to you here. The AND operation, what it does is it will take the, who is taking? PC is performing, okay? Source IP. Source IP is what?
10.1.1.
He will take the source subnet mask. What is that source subnet mask is? /24 means this value, 0. Okay. The output which will come is, what is AND operation? What does it say? Any value which is non-zero is same number. Am I correct?
Yeah.
So what should we get here? 10. Then 1. Then 1. Then 0.
0.
Correct? This should be the value. Now in the same manner, what he'll do with the destination, he'll take the destination IP 10, 1, 1, 2, and he'll apply which subnet mask? The same source subnet mask, because he doesn't have any idea about what is destination IP subnet mask. That is the reason why he'll only take source subnet mask. So what value will he get?
10.1.1.
1.0.
Is
Yes.
clear? Now both are in same network or different network according to this value.
Same network.
Same.
So okay. Is this thing clear? This is
Yeah.
our AND operation. Now once our AND operation is done, what next thing? What is the next thing done?
Moving to layer 2.
Correct. This is hand over to layer 2.
Layer.
Now I'm calling this directly as packet. Okay, I don't have to mention again the whole thing. For simplicity, I'm calling it as packet. Fine. Along with this packet, what is encapsulated?
Uh, frame header.
MAC addresses.
Correct.
MAC addresses.
Actual communication happens, so we need MAC address.
MAC addresses.
What is our source MAC? If I have written, it is
0B.
0B for simplicity. Fine. Now,
Yeah.
what is our destination MAC? So for the first time, when the packet
0.
is,
Oh.
no, here there is a note. For the first time, when the traffic is initiated, we don't have any information of destination MAC address. Am I clear?
Okay.
So
Yeah.
for now, the destination MAC would be unknown.
Okay.
Now the next field is what? Type.
Type
What is the type? Who has given this packet?
IPv4
So the value would be.
0808.
So now, since destination MAC is unknown, the frame is incomplete, correct?
Mm-hmm.
Firstly, before the frame is incomplete, destination MAC is unknown. But initially our table is empty and it will not have any destination MAC information. Hence what happens? Hold. Okay.
Okay.
And why this process is hold? Because the destination MAC is unknown. Fine. Now, once this process is hold, now the frame is incomplete. You can say if why this process is hold because the
Game is incomplete.
why the frame is incomplete because it doesn't have
Des destination
destination
MAC
MAC
Destination
address.
Mac.
address. Fine. Now, I told the process is hold. Now, what the PC will do is PC will call firstly, let me highlight the ARP tables. Every device will have an ARP table. Okay, I'm considering this as an ARP table. What is the information which is there in the ARP table means IP with MAC. Am I clear? Let's say initially it will have its own information 10.1.1 and what is the MAC address? It is
0 B.
0B.
Yeah.
So it doesn't have any destination entry, correct? In the same way, in PC2's ARP table as well, it is A. It doesn't have any information about PCA. Now, okay,
Okay.
Reason why it is called as layer 2.5 protocol, you'll get to know shortly. Okay. Now, ARP is basically layer 2.5 protocol. Again, ARP has two different messages. ARP request, ARP reply. This is for human understanding purpose, but for machine understanding purpose, we have operational code, which is in short form, it is called as opcode. If it is opcode 1, then it is considered as ARP request. If it is opcode 2, then it is considered as ARP reply. Now, what is the job of ARP? Am I clear? To resolve the MAC address for the known IP address. What is our known IP address over here?
10.1.1.2.
Correct. 10.1.1.2. So again, here, if you consider, what are the mistakes made by the engineers while they answer the interviewers? Interviewer, when he asks question about ping process, or when he asks question about ARP, then people say the definition as ARP resolves the destination MAC address for the destination IP address. Completely wrong definition. ARP doesn't know whether it is destination IP or whether it is source IP. It only knows that it is an IP address, and I need to get the MAC address for that IP address. Am I clear with this thing?
Yeah.
Yeah.
Okay. So it treats source IP address and destination IP address as same, like one thing.
The job
And
of ARP is to resolve the MAC address for the IP address. That's all. If he has the IP address, he has to resolve the MAC address for
MAC
that
address.
IP address. Am I clear?
Okay.
Yeah.
And just to make a note, there is another ARP as well, which is called as inverse ARP. Okay. What that inverse ARP will do is, it will do vice versa. Vice versa means
Using
exactly
the MAC address, it will find IP address.
correct. In that case as well, people say destination IP address, destination MAC address. Completely wrong. There's no source and destination. It's only about IP and MAC. Am I clear with this thing?
Yeah.
Yes.
Okay. Now, for the known IP address, fine. Let's start with ARP header. So what the fields in ARP header is sender IP. What is the sender IP? Correct?
Yeah.
Yes.
Sender MAC.
0
What
bit.
is it? Okay.
0 bit.
Target IP. What is the target IP?
Endpoint.
1.1.1.2.
Now, what is the target MAC? This is what is to be filled.
None.
So there is no target MAC over here. So it will mark as zeros in
Zero.
hexadecimal. Am I
Okay.
clear?
Okay.
So this is the information which is filled and sent back as a reply. And one more important thing for the machines to understand whether it is ARP request or ARP reply. So opcode would be 1. Reason why it is 1, because this is ARP request.
Request.
This is your ARP header. Am I clear? Now,
Yeah.
Okay.
as one thing I was mentioning, why ARP is 2.5 protocol? Do you see the header? You should see something.
No header.
Compare this with IP header. What are all the fields involved?
Source and destination.
Correct. So this is half of IP header, if I'm not wrong. Check here.
Yeah.
Yeah.
If you divide this line, correct?
Mm-hmm.
So half means 0.5, correct?
Okay.
Yeah.
So that is the reason why it is layer 2.5.
2.5.
Basically, people say it as layer 2, but I do say it as 0.5 as well, because it, it do have IP information as well. If it is purely layer 2, how come IP information would be there in layer 2? Correct?
Oh yeah.
Correct.
Now another question. IP information will only be in layer 2 if packet has handover to layer 2. And do layer 2 have any information of IP address? Does layer 2 know that inside packet there is an IP address? Do you think so?
No.
Why?
Because of MAC address? No destination MAC address. Something
No.
like that.
Is he authorized to open the IP header?
No.
What is the litigation in that, or what is the limitation in that? Why can't he open that?
Because it may tamper with IP address.
No.
Is that
There
correct?
is a checksum involved.
Okay. Yeah.
Who will do that checksum? Which layer?
Only network layer for IP. IP data.
Network layer for IP address, correct? IP
Yeah.
header.
Yeah.
So does he have any information of that checksum related to IP? Can he do that?
Uh, uh,
See, checksum is there in each and every individual layer, each and
yeah.
every header,
Yeah.
like the way I mentioned before. So reason why he cannot open is because of checksum. In order to
Okay.
open it, firstly he need to calculate what? Checksum.
Checksum. Yeah.
Only if checksum is matched, then only he is able to open that one. Not
Correct.
he is able to. He
Okay.
will open only if the checksum is matched. Correct? And that
Yeah.
checksum calculation is only done by network layer if he
Network
want
layer.
to open the IP. So what is the
Okay.
job of layer 2? Is to open the MAC information. When
MAC
he'll open
information.
that, again he'll calculate his
Checksum.
FCS, that CRC
Okay.
algorithm FCS. Correct?
Mm-hmm.
So FCS is similar to checksum, but in layer 2 we don't say it as checksum.
Checksum. Okay.
Correct? Now, so that is the reason. This is the way you need to put questions and then study. Then you'll understand. Am I clear in my explanation?
Yeah.
Yes.
Fine. Now, the job of ARP header is done. Now this ARP is hand over to which one?
Layer 2.
Correct.
Layer 2.
There is no IP involved over here. Remember that. Okay.
Okay.
Meaning IP protocol is not involved in this one. That is what I'm trying to mention. Now, and this layer 2. Now, for simplicity, not for simplicity, let's copy it. No worries. along with this ARP. Now this ARP is handed over to layer 2. Along with this one, what is the thing which is encapsulated
Uh,
in layer 2?
Source map?
Source
Correct.
MAC and this.
Always in layer 2, source MAC would be there. Okay. Don't confuse with sender MAC and source MAC. Both are same, pretty much the same, pretty much similar. But this is specific to which one? This is specific to only ARP. Okay. Layer 2 doesn't know that what information is there in ARP header. He doesn't know. Who doesn't know? Layer 2.
Layer 2.
Layer 2 only knows that some some information or some data has come to me. Along with this data, I need to attach my header to make the actual communication possible. Am I clear with that point?
Yeah.
Yeah.
Now, source MAC. What is the source MAC? Exactly the same which is mentioned in the ARP header.
Yeah.
0B.
0B.
Now, what is the destination MAC?
All zeros.
No, all zeros is specific to ARP header,
APR header.
ARP header, not APR.
Yeah. Oh yeah, ARP.
Yesterday, I've told something about global broadcast address. Remember?
Yeah.
FFF. Okay.
This is the global broadcast address. Okay, this is
Okay.
used over here. Now, other field, what is left?
Type.
Type is left.
What is the type over here for ARP?
128.
No, don't confuse with TTL and ARP. See, type is different and that is different.
Okay.
Don't study just to remember. If you do so, you'll forget. I'm pretty sure.
Type is like IP address, like IPv address, right? Like IPv 4 or 6, depending on that.
Right. Not IPv4 or 6. What is this type mentioning is he is having some data which he has received.
Mm-hmm.
Who has given that data is dependent on this field.
Okay. The address
Okay.
of the like header.
Am I clear?
Yeah.
Yeah.
0x0806 means who has given this data to layer 2?
ARP.
What?
ARP. No.
Correct. Exactly. ARP is the one who has given this data. So once again, I would write those type values for you.
Okay.
If it is given by IP version 4, what would be the type? 0.
0x800.
800.
If it is given by IP version 6, the value would be 86DD. Okay.
Okay.
If it is given by ARP, the value would be
0806.
clear. So these are the things.
Are there any other types?
There are,
Or
but for now,
okay.
only consider this.
Okay.
Okay. Depending on the understanding. See, if you understand basics, right? Why the type is used. Obviously, who has given this data? Obviously, the type value would be this one. If you Google it, you'll find the list of the type values as well. No worries.
Okay.
But if you understand the basic, then advanced is very pretty much the same, right? What is the difference except the value? Am I clear?
Okay.
Yeah.
Yeah.
So concentrate on the basics. Advanced would be easy if you concentrate. If you're strong with your basics, right? I can assure you that any advanced topics would be easily understood by you.
Okay.
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 Yeah.
Now, what
I
is
have a
this?
doubt. Like,
Yeah, go ahead, please.
Yeah, destination MAC, like it was unknown in the previous, like when it was like handover to the layer 2, right? It had to go through the ARP. Instead of going to ARP, why can't it like directly store the universal MAC address, like destination MAC address, like the FFFs?
Okay, correct. Now, depending on what he is giving the universal or global broadcast address, depending on whom he is giving that, with whose support,
Oh, okay. Yeah. Now it's
correct?
support like ARP is supporting for
Correct.
the address.
Why?
Okay.
Now, depending on he's the boss, right? Though he's not able to control, but he has the control by using which field? By using this field.
Okay. Type. Yeah.
Okay. Okay, ARP
Okay.
has given me, so I need to put this value. Am I clear?
Yeah.
Yeah.
So just for simplicity, I guess you both are from India, right?
Yeah.
Yeah.
Okay. So if there is any convoy which is about to leave or about to come or whatever it might be,
Mhm.
do you think that the person who is there in the convoy is definitely known to the constables or home guards who are lower levels?
No.
Correct, right? To whom
Mm-hmm.
they would be
Mm.
known? To the higher officials
Higher officials.
only. Reason why they are known only to higher officials? Because that is the way
Security.
they are secured. Correct? In the same
Yeah.
manner.
Okay.
Take
Okay.
that example over here. Consider this as constable or home guard or some lower level candidate. It is not necessary for him to know about this convoy or the person who is sitting in the convoy, but he knows exactly what is this. This is a convoy. He doesn't care about the person who is sitting in the convoy, be it a driver as well. He doesn't care. If convoy
Okay.
is coming, he need to attach this. That's for sure. Depending on the convoy. Am I clear?
Okay.
Yeah.
Any doubts?
No.
Okay.
No.
Now, what is this entire thing called?
Frame.
Okay. Now, this frame is hand over to which layer?
Uh,
Physical layer.
Physical.
Correct. See, there is no direct contact or direct transferring of data. This is ordering only. Definitely the order is there. He, it is the encapsulation process only. He cannot bypass anything. Okay.
Okay.
So don't be in doubt whether the physical layer will come or not. Physical layer will definitely come. Without the physical layer, there's no communication. Frame is hand over to L1. Now, frame is converted to,
Bits.
Bits.
so the transmission is in the form of electrical signals. Reason why I'm considering it as just
Wired.
a cable, wired communication, that to Ethernet. Okay.
Mm-hmm.
Okay. Now, one important thing to be understood. What is this called? Layer 2, global broadcast address. Okay.
Okay.
Now,
Okay.
layer 2 global broadcast address. Okay. Now, does the ARP really know where this device is? Do you think so, logically speaking?
No.
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 No, right? So, reason why layer 2 broadcast address is broadcast means what? One to all.
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 One to whoever is connected to it, meaning whoever is in the same network. Am I clear?
Okay. Yeah.
Yeah.
Let's say if some unknown person is entering your organization requesting for your name.
Mm-hmm.
Do you think the one who is available really know your name and means he knows your name? That's for sure. He knows the IP address. That's for sure. But do you really think that he'll directly come to you? That he knows that you are available only in this particular cabin? Some unknown
No.
person I'm talking about, some peon or something like that. You can consider in that manner. Just to make this concept clear, I'm taking that example. So that would be broadcasted to each and everyone. Broadcasted in the
Yeah.
sense possibly an announcement you can consider like that, right?
Okay.
Someone has come for you, please come. That announcement is heard by everyone, right?
Mm-hmm.
Yeah.
Do you think everyone will come over there?
No, only the
No.
person.
Only that person. That means,
Person.
though it is broadcasted, who will respond to that broadcast request?
Only that
That
IP
specific IP
address.
address,
That.
correct? The
Mm-hmm.
similar
Mm-hmm.
manner, same case happens over here. So here I've taken only single device is connected. Let's say I take a switch. Okay. I'll take a switch over here and I'll assume that there are multiple connections, multiple devices connected to switch. Let's say PC1 is connected over here, for example. Okay. He has broadcasted request for PC2, but I have two extra devices as well. The moment the
Mm-hmm.
request, broadcast request reaches over here, switch will broadcast this to each and every device. To this device,
Okay.
sorry, uh, to each and every device in the same organization, in the same network. Organization means same network, I'm considering. Am I clear?
Yeah.
Yeah.
So that broadcast request is sent to each and every device in the same network or same subnet. Now, each and every device will will receive that request. Then they'll open up and they'll see whether this is for me or for anyone else. The moment they'll open, they'll come to know this is not for me. So I'll drop this or discard the frame. Am I clear?
Okay.
Now the question may come. Since this is global broadcast address, what is the first thing? Firstly, layer 1 is converted to frame, correct? Inside the
Mm-hmm.
frame, the
Mm-hmm.
destination MAC is opened. So destination MAC, seeing the destination MAC, every device will accept that, correct? So
Yeah.
source
Yeah.
device, he'll hand over it to our protocol. Okay. Then what happens?
Mm-hmm.
By seeing the target MAC, also they'll accept. But seeing the target IP, what they'll do? Oh my God, this doesn't belong to me. I'm dropping this. Am I clear?
Okay. Yeah.
Okay.
So they have the right to open up to here. How they are opening up? Similar process.
Using the MAC address. Yeah.
Correct. Firstly, it will hand over this to layer 2. Inside layer 2, FCS is checked first. Then seeing the global destination
Global.
MAC address, they will accept it. This is for everyone, right? Anyone can take it. This is global.
Mm-hmm.
So after seeing this, they will accept it. Then by seeing the type field, they'll transfer this to. They'll hand over this to upper layer, which protocol? ARP.
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 Yeah.
Once the ARP receives it, ARP will open target MAC. Once the target MAC is opened, he'll check target IP. Oh my
Mm-hmm.
God, this target IP is not for me. I am not the one who is authorized to open it. So I am discarding or dropping this one. Am I clear?
Yeah.
Okay.
This happens within a fraction of seconds. Fine. Now, like the way I told, what happens exactly here? Bits are transmitted in the form of electrical signals, and this is what exactly? Wait, let me delete this first. This is and it is always
Broadcast.
reason why it is broadcast.
To send it to all.
All
Not send it to all. Reason why it is
repetition.
broadcast because of this
FFF.
MAC address.
MAC address. Okay, because of this Ethernet layer 2 MAC address only it is broadcast. Okay. Now, once this broadcast is received over here, again the decapsulation happens. Like the way I told, it is converted to frame.
Frame.
After converting to frame, what is the first field which is checked? Firstly, FCS. After FCS, what is the first field? Destination MAC.
address.
Mac.
Yeah.
By
Yeah.
saying this, since this is global, all the layer 2 devices, all the layer 2 will understand this. So they'll accept it. Then next field, they'll check this one. They'll hand over it to ARP protocol. After handovering, ARP will check target MAC. After checking, he'll check
Target IP.
target IP. Okay,
Target
this
IP.
is for me only. Who is sending it? He'll enter these two information in its which table? ARP table
ARP
over
table.
here. Okay.
Table.
10.1.1. There is device in my network whose IP address is 10.1.1.1 and whose MAC address is
0.
0B.
now. After that, what is the field which he'll check?
Opcode.
Code. Okay.
So, okay, this is ARP request. So I need to generate what?
Reply.
Ops,
ARP
reply.
reply on behalf of this ARP request. Now, what are all the fields which are changed for the ARP reply?
Opcode and destination.
Target.
IP addresses will be vice versa.
Vice versa. And
Now, sender MAC, what would be, sorry, sender IP firstly. Sender IP would be this time.
10.1.2. Yeah.
Now, sender MAC
0.
would be 0,
0
A
A.
this time.
Okay.
Next,
So,
Destination.
destination.
Alright, target.
target IP would be what?
10.1.1.1.
Target MAC, what?
0.
0B.
Opcode.
2.
2.
Clear? Now ARP header is done. Now next, what is a header? After this is handover to layer 2.
Layer 2.
Now this is handover to layer 2. Okay. Now layer 2 along with this one.
Mac. Mac addresses.
Let me copy this. Along with this one, he'll attach what?
Mac address.
Source
Source
MAC.
Source MAC address. 0A.
0A. Destination MAC address 0B.
0B.
Now, why are we not having any broadcast over here? Because it is known, right?
Yeah. Data is known.
Sorry, not opcode. Type. What is the
Type.
type?
0806.
Still, it is ARP only, right?
Yeah.
Fine. This frame is again
Send back to PC1. Like physical. Layer 1.
frame. Now this is handover to physical layer.
Physical layer.
Okay.
Now here frame is converted to
Bits.
bits and placed in the physical media. Now this time this is unicast. It won't be sent to any other device except the exact device. Why? Because there is no global broadcast address involved. So ARP reply is what? Unicast. Reason why it is unicast because it doesn't have any broadcast address in which
Broadcast
layer?
address. Layer 2.
Correct. Am I clear now?
Yeah.
Yeah.
So always the ARP request is what?
ARP request is broadcast.
Broadcast.
Hope you know the reason why it is broadcast. Now, ARP reply is unicast. Hope you know the
Unicast.
reason why it is unicast. Now, something we told process is hold, right? If you remember.
Yeah. ICMP process is hold.
So ICMP timeout is basically 2 seconds.
Okay.
Okay.
So one more thing. ICMP doesn't really have any idea that there is an ARP involved. There's a protocol involved named ARP. Okay.
Okay.
ICMP
Okay.
will say I am sending the request. I need the reply within how much time?
2 seconds.
2 seconds. If I don't receive any reply, I'll discard and I'll regenerate it. Am I clear? Regenerate what? Regenerate the request.
Request. Okay.
Reason why am I regenerating? Because my 2 seconds are done.
Okay.
Now, again the same process. Which process? This one. But this time what is filled? Destination MAC is filled. Because I have the destination MAC in my this entry. We have the entry, right? How did you get that entry? Because of ARP. Okay. Now, this time you have the destination MAC entry and it is filled with
0A.
A. Now, again, this is hand over to layer 1. And what the layer 1 will do, convert this frame into bits and placed on this physical media. Here there is no broadcast or unicast, broadcast, only unicast is there. Reason why? Because every field is there, exact, specified. Now this ICMP is sent, ICMP echo request is sent to PC2. Now after sending, what the PC2 will do? A decapsulation process.
Reply. Yeah.
Don't say reply directly. First it will decapsulate.
Directly first.
Hope you will understand that process, right? By yourself, or do I need to explain it again? How the decapsulation happens. I'll mark in the same one. What do you say? So that it would be easy for me.
Yeah, that's fine.
With some other color, for example, this color. Okay. Now, firstly, the bits are converted to frame for decapsulation. Now, after that FCS is calculated, once the FCS is matched, what is the thing which is firstly checked? Destination MAC address. Once he checks this one, what he'll understand? Okay, this is coming for me only. Am I clear?
Yeah.
Now, after that, it will check the type field. Why is it checking? In order to understand whom to hand over the leftover data in layer 3. He knows to hand over that to layer T, but to which protocol exactly? To IPv4. Why IPv4? Because this value belongs to IPv4.
IPv4.
Once this comes over here, what is calculated first?
Checksum.
Correct. Checksum is calculated. Okay. Once the checksum is matched, what is the first field which is checked?
Destination IP.
Correct. This is whether this is coming for me or someone else, right? By seeing this IP, I'll understand that this is coming for me. What is the next field which I'll check?
Protocol.
Why? To understand whom to hand over the leftover data or leftover payload, you can say. So I'll hand over it to ICMP. Why I am handovering it to ICMP? Because my protocol
protocol is
value is
one.
1. Once I hand over this to ICMP, ICMP will open its header. Then by seeing this type 8 and code 0, he'll understand, okay, this is ICMP echo request. I need to generate ICMP echo reply.
Echo reply.
Now this type 8 and code 0 is replaced by what? Type 0 and code 0.
Yeah,
Yeah.
Reason why it is replaced like this? Because it is
because it's a
Because
reply.
it's reply.
ICMP echo reply. Am I correct? Now these two are
Yes.
inversed. Correct? In
Mm-hmm.
reply. Now protocol remains the same. TTL
Same.
remains the same because
Same.
that is initiated.
Same.
There is no layer 3 device involved over here. Am I clear?
Okay.
Don't
Yeah.
say the TTL is decremented. No, TTL will never be decremented in PCs.
Okay.
And also TTL will never be decremented in the same network. Main important
Yeah.
point to be remembered. Okay?
Okay.
Because there is no routing required.
Routing, yeah.
Simple thing.
Yeah.
After that, once this packet is complete, packet is handed over to layer 2.
Layer 2.
Source
The
MAC
MAC address is add. Yeah.
inverse 0
A.
A
0
is
B.
0B, then 800. Okay,
Yeah.
same. Then
Frame is 10.
physical layer. Then the same process. Reply will come over here. Okay.
Okay.
Is this thing clear or any doubts?
Clear.
No, it's clear.
Now, how you should understand this? First, you need to make the notes. Like the same way how I have explained this thing. In the same way, you need to make the notes. How? Firstly, you need to take these diagrams. Step 1, what happens? Step 2, what happens? Step 3, what happens? In this manner, you need to write the steps in your notebook. Only then in which step what exactly is happening, you need to understand that. Am I clear?
Yeah.
Yeah.
Yesterday itself, I have explained to you this thing. Not exactly the ping process, but the R process. Yesterday itself, R process would have come. Why? Because if it is initial process, let's say initial packet, and I am initiating telnet without the without the MAC address, telnet is impossible for me. Am I clear?
Yeah.
So there as well, ARP will come into action. Only in the case where I doesn't know destination IP. Destination MAC address.
Okay.
Wherever there is a scenario where the destination MAC address is unknown, there I'll call ARP.
Art.
So remember this thing,
Yeah.
each and everything is important. Don't be in hurry to answer the questions whenever the interviewer is asking. There is some logic which he is expecting. What is that logic is this one. Everyone knows that TTL is decremented, but when is it decremented? If we'll give you this scenario, definitely people will be confused. Why the TTL is not decrementing? For now, since I am there, you won't be confused. But let's say I'm not there. You don't know the concept. Suddenly you forgot something. It won't strike. Am I clear?
Yeah.
Yeah.
Okay.
So remember this thing. Concentrate on each and everything, each and every part.
It's a ping process. This ICMP is all for pinging, ping command, right? I mean,
ICMP is basically called as management protocol.
okay.
Beyond the ping, it does many things.
Okay.
Okay, what all the things done by ICMP is, let me explain it to you today itself. Okay, no worries.
So my doubt is, you for ping process, you explained all about ICMP.
Correct.
So in ping we have this time also, like round trip time also.
Correct. That
Yeah,
round, yeah.
where it is calculated, like
How is it calculated?
How is it
Yes.
calculated? Like I told, we don't have control on it.
Okay,
Exactly
so
at the back end, there is some timer run. Reason why the timer is run is simple, because it cannot be like it has sent the request and reply has got, there has to be certain time frame, right? So for
Uh-huh.
now, it is reaching and we are getting response. What if it is not responding? Till what time should I wait?
yeah,
Depending on this, what is calculated by network engineers? Depending on this, the latency is calculated. I am saying 31 milliseconds, correct?
Okay.
okay,
See, if you observe these four packets carefully, one moment, yeah. If you observe these four packets carefully, observe the timer. Sometimes it is taking 30, sometimes it is taking 31.
Mm-hmm.
There are scenarios where you will see 267, something like that. That is huge latency. Okay. Always in milliseconds, the timer should be less value.
yeah,
Okay.
Reason why we see the timers is only to check the latency value. Am I clear?
okay,
Okay. So this timer is only calculated in the, I mean, in the PC or the source, not in the not in due to ICMP, right?
No, not this timer is basically, see, if that question is exactly correct, if you apply your logic, you'll get the answer for that. Again, I'm saying reason why. Oh, whatever these are happening, who is the main boss of this one?
PC, yeah,
Correct? Without PCB knowing, these cannot be resulted. Who is calling those protocols?
PC,
Who is calling OSI? PC again.
PC. Okay,
Everything is called by PC. Who is performing AND operation? PC again. Okay.
okay,
So those timers will be controlled by PC, but it is not like what we call, say, let's say what happens is, I'm the PC, for example. I have sent the request. I've started my timer. I'll fix this threshold to be some milliseconds. Okay, I'll wait for this many milliseconds. If I don't receive anything, I'll directly stop. I'll assume that
okay,
the request has not been reached to the destination. Am I clear?
okay.
yeah.
Now, one question is there for you. What is the port number of ICMP?
On
It is not generated at the transport layer, right?
Correct. This is common question which is asked in the interview. People say one. Interviewer won't say anything. He'll say very good.
Okay,
Be sure with your concepts. Okay. So interviewer will ask by saying this, what do you understand by these things? He won't say where the timer is calculated, who is calculating the timer, how it is calculated. No, he won't ask in that manner. Reason why that is not at all necessary. What is necessary is first question. Why is this timer calculated? Simple thing, if I initiate a
explanation.
request, I cannot keep on waiting, right?
Yeah,
hmm?
So in order to have threshold on my waiting, you can speak logically. He won't say anything. You don't have to give the exact answer. Am I clear?
mm-hmm.
Okay,
Yeah,
See, if I'm generating anything, any packet, I have the timer threshold, because there might be possibilities that packet could not reach the destination for XYZ reasons. Might be devices, some intermittent device is down, might be some intermittent device cable issue, port issue, many scenarios, right? So I have to stick to a threshold. This threshold is decided on me only. I myself deciding this threshold. Am I clear?
Okay.
Yeah.
But ICMP timeout 2 seconds is common on every device. That is specific to ICMP only, not to PC.
Okay.
Okay.
Correct? But the
Yeah.
thing, the timers which you are seeing is in milliseconds. That ICMP timer is not at all related to this one. Am I clear?
Okay.
This
Yeah.
is PC is calculating how much time is taking for my request to reach the destination and how much time it is taking for my destination to reply to my request. Am I clear?
Yeah.
Yes.
Understood.
Or is there any confusion?
No,
Clear.
Did you get the answer for your question or still confused?
no, it's clear.
Okay. So I am putting you in a direction where how interviewers will expect you to answer. Am I clear?
Yeah.
And the other thing, this one,
TTL. Okay.
why this is decremented? Because we are not generating any PC to PC ping over here.
Oh, that's because of
Obviously,
the router. Yeah.
obviously this is in which network? 8.8.8,
Mm-hmm.
different network. How will I get to know that this is different network?
By
By checking, submitting, end operation.
yeah, and operation.
Okay. So you need to be sure with this thing. So this is the way you need to put a question to yourself. Only then you'll understand the process. Very easy. It's very easy. Okay.
Okay.
Shall I start with any other concept?
Mm,
Yeah. You didn't teach IP subnetting, so I think
Okay. You want me to start IP subnetting right now?
uh, if it can complete within half an hour, then I think it.
So it's 1936. One moment. Okay. Mm, IP subnetting. Okay, I'll do one thing. I'll make you understand the basics like the way I do, but I won't discuss as many practices as you require. Reason why? Because that is lot of time waste process.
Okay.
Though it is important in terms of CCNA's perspective, but no one would really ask any questions. Okay. I will have my notes handy to you. Let's see, where is my notes? Have I written anything? To which batch I have told? I remember. Okay, no worries. Mm, submit mask. Okay. Before going to that, I want to explain you something called broadcast domain and collision domain.
Okay.
But I think I need to explain what is switch as well. Okay, no worries. Where is my screen? Yep. Okay. I think today it won't be finished. Okay. I would require more time. Tomorrow for 1 hour, I'll discuss the subnetting. Then we'll start with some other concept.
Okay.
Now we'll discuss small concept. What is broadcast domain? So, do you know anything about what is hub?
Yeah, like hub will send data to all through all the ports except for the incoming port, right?
Correct.
That's what I
Exactly.
know. Yeah.
You're right. Okay. So let me explain it to you with the diagram. Okay. Now let's say, okay, I'll draw it for you. Let's say this is my PC and this is my hub. This is another PC. This is another PC. This is another PC, which is connected to hub. Okay. Now I'll take some other color. When anything is broadcasted, for example, you consider R. This hub doesn't understand anything about collision domain or broadcast domain. He'll directly just give it to dumb device. Just he need to forward it to any other things. I could say this as dumb device. Okay. This doesn't know anything except to forward the data which is received on one port to all the leftover ports except the port on which it is received. Fine. Now, what is broadcast domain is, it is a domain or area in which if any device broadcasts any request, all other devices in that specific same domain will receive that specific request. Am I clear in the definition or any confusion? It's simple thing.
Clear.
In specific domain or in specific area, if anyone is broadcasting something, all other persons or all other devices in that specific broadcast domain will receive that specific request. Simple thing. Now, what is a collision domain is, again, it is a domain or area in which there is a chances of collision if two devices. Here for collision domain, I want to take an example of railway track and a train. For example, there is single track. Okay. If, for example, two trains are coming on the single track at a time in opposite directions, is what is called collision domain. Am I clear?
Okay.
Where that exactly happens is in case of your half duplex scenario. In half duplex, what is the limitation?
Only one can transmit or
Only one can transmit at a time, correct?
okay. Yeah.
What if two persons try to transmit at a time? Collision happens, right?
Collision happens.
So that's same thing. So this is the theoretical explanation of broadcast domain. Now we'll understand that broadcast domain from switch perspective. Okay, this is switch. Now, switch is a layer 2 device basically. So I would consider some PCs. These are the PCs connected to. Now, if you consider this switch by default has single broadcast domain and per port collision domains. Am I clear?
Yeah.
This red one is the broadcast domain. Okay, red colored one. And say this colored one is the collision domain. Am I clear?
Okay.
Why? What is the reason behind switch having only one broadcast domain and multiple collision domains? Again, if you talk about collision domain, where is it exactly? Meaning it is port specific, right? Or interface specific, you can say. At the time, what I'm trying to say, at the time, any device, if it is trying to send any data, if you assume this particular part, okay, these are considered as two devices, right? Correct or wrong?
Okay. Yeah.
So they have the ports where for the data exchange, for where they exchange the data. Am I correct?
Mm-hmm.
So from this port to
Yeah.
this port and this port to this port. If I by default it is full duplex. If I convert it to half duplex, what happens?
So only one port can send at time.
Correct. So let's say, for example, I have converted it to half duplex. At the same time, PC is trying to send some data. Switch is trying to send some data to PC. What is the data which switch is sending is from the different PCs, some broadcast request has received. So it is trying to send the same broadcast request to that PC. Okay. Then what happens? Definitely collision domain, right?
Okay.
Just to make you understand, let's say this PC has sent some data. I've converted this to half
Half
duplex.
duplex. Okay.
Now, this is a broadcast request. Each and every device will receive this one. So similarly, this PC will also be receiving that one.
Receive.
At the same time, for example, this PC has generated a broadcast request. Then what happens here?
Collision occurs.
Correct? So this is where means collision domains means where there are the chances of collision. That is what is collision domain. Broadcast domain means where there are the chances of broadcast.
Broadcast. Okay.
Clear?
Mm-hmm.
So why switch has only
Yeah.
one broadcast domain? So there is a concept in the switch called switch is basically which layer device? Basically, it is layer 2 device.
Layer 2 devices.
Even we have layer 3 switches as well. But that layer 3 switch as well is by default in layer 2 only
Okay.
until and unless routing is enabled on that switch.
Mm-hmm.
Once the routing is enabled, it will function in layer 3
Layer.
as well. Correct?
Okay.
Okay. When the device is set to be in layer 3, obviously when it is capable of doing what?
Routing.
Correct. So by default, the switching is done in layer 2 only. If in case you have enabled routing on a switch, not all switches are capable of routing. Remember that.
Okay.
Only layer 3 switches, which are high end, are capable of routing. But by default, they do only switching. Only if in case you have enabled routing, then you can say that to be a layer 3 switch. Am I correct? Sorry.
Hmm.
Am I clear?
Okay.
Fine. Now, what the switch have is different ports, right? So by default, VLAN 1. All the ports are member of VLAN 1. What is this VLAN is? VLAN stands for virtually there is single LAN by default on the switch. Physically switch is one, but to that physical switch there is one LAN. Okay. What if I want multiple LANs in that switch? I can do that by division of VLANs. Then what happens is my number of broadcast messages will increase,
Increase. Okay.
and it is limited to that specific VLAN only. Am I clear? Let's
Okay.
say this is my switch. Okay. What I told, all the ports initially are member of VLAN 1. This entire control is on which VLAN? VLAN 1 for
One.
now. Now what I have done is I have taken the same, sorry, I'll, mm, I'll take this color. I've taken the same switch. What I have done now is I have divided the switch. What I'm trying, how am I dividing? I'll assign some ports to VLAN 2. Rest of the ports will be in which VLAN? Obviously VLAN 1, right? Then what happens? Here one broadcast will be there. Here one broadcast will be there. Broadcast domains. Am I clear?
Okay.
What I'm trying to explain over here is why the switch is having only single broadcast domain initially, because switch, all the ports in the switch are member of VLAN 1. Now, here in this case, what I have done is I want two broadcast domains on a switch. For that, what I've done is I've created another VLAN and I have given some ports to VLAN 2 from VLAN 1.
Okay.
Okay. Now what happens? There are two broadcast domains on the switch. Clear?
Mm-hmm.
Number of VLANs is equal to number of broadcast domains. Simple concept. Confused?
Yeah, like, can you explain
No, clear.
more about VLANs? Then it will be clear.
Okay. So basically VLAN two raised to power 12, how much?
4096.
Okay. So if it starts from 0, how much?
4095.
Now, this is the range of VLANs. 0 and 4095 are reserved VLANs. Okay. Now, what are remaining?
1 to 4094.
Okay. Now, again, 1 is the default VLAN. 1001, 1002, 1003, 1004, 1005. These are also reserved VLANs. Okay,
Okay.
not in used, unused VLANs, you can say. Never used. You cannot modify or delete this one.
Okay.
Okay, now even you cannot modify VLAN 1. Okay, all of them. Now, what are the leftover numbers? Okay,
Mm-hmm.
so this is the range of VLAN which we use. Exactly. Fine. Now, what I'm trying to say over here is, sorry, not
One,
1006. Two is also there.
2 to 1000.
2 to 1000. Okay, and this range are there. So this range is called. Where is that man? One moment. That hyphen. Okay, I'll write it like this. Standard VLANs. And this is called. Fine.
Okay.
So this is all about the classification of VLANs. Fine. Now, by default, all the ports on the switch are member of VLAN 1. And also we have these VLANs, but these VLANs doesn't have any ports reserved to them. So by default, a switch has how many VLANs in total?
6.
Correct. So five would be, I believe five would be reserved VLANs, and this one is default VLAN, which is also there. Fine. Now, have you got any idea about VLANs now? Some idea at least?
Yeah.
Okay. This is the classification. Now, VLAN is created like, let's say, I have given VLAN 1. VLAN 1 is anyhow there. Apart from VLAN 1, I am saying VLAN 2. It is a name given. After that, I am assigning some ports. Let's say port 3, port 4, port 5 are member of VLAN 2. Clear?
Mm-hmm.
So for 3 ports, VLAN 2 is there. For rest all ports, who is the owner? VLAN
VLAN
1 is the
1.
owner. Clear? Now, what I am trying to say is there are two broadcast domains for switch. One will be in VLAN 2, other will be in VLAN 1. Simple thing. That's what I'm trying to mention. Any
Okay.
confusion still?
No.
You can just consider just a segregation of flats. Simple thing for one specific building.
Okay.
Fine. That's the thing. So switch by default has single broadcast domain. In order to explain the answer why this has single broadcast domain, I have entered into VLAN concept. That is the only reason. Am I clear?
Okay.
Mm-hmm.
Now, so if we talk about router, this is the symbol which we use for router normally with, you can say, sorry, with this symbol. meaning this X should be in bigger value somewhere here. Okay. So this is the router symbol. Normally it is like this. Let's say first I'll draw X, then I'll take the router. That way it would be. This is the router symbol. Okay. Now for router, you have per port broadcast domain and per port collision domain. Why? Because routing is involved. So each and every organization is separated depending on the subnet. This is finance department. This is some other. This is some other. Clear? This is some other. Am I clear?
Okay.
So that's why you have per port broadcast domain and per port collision domain. For what? For router. But switch has per port collision domain, single broadcast domain. Initially, okay, we are not dividing any VLANs, but just for explanation, I told about the VLAN division. Fine.
Okay.
Any doubts in this?
No, not right now.
Okay, fine. So this is the thing. All right, then if we are done, then we can wind up. Fine.
Okay.
Tomorrow we'll see what is subnetting and how exactly the subnets are divided. Just an overview with some examples if possible. Okay,
Okay.
fine then. Have a nice day. Bye.
You too. Bye.
Yep.
Bye.